Chapter 8 is a vital part of inferential statistics. This is where we focus on what we call hypothesis testing. So in section 8.1, we're going to take a look at the steps of hypothesis testing for a traditional method. And then within each section here from 8.2 to 8.4, there's going to be other ways to go through hypothesis testing. So section 8.2, depending on the information we're given, just as we saw with confidence intervals, we could use a z-distribution. So it's called a z-test for a population mean. 8.3 would be a t-test using a t-distribution, so a t-test for a population mean. But if we don't have a population mean, we may have a population proportion. And for that, we would go back to the z-distribution and use a z-test for a proportion. So for section 8.1, the steps in hypothesis testing, the traditional method, the objectives here are to understand the definitions that are used in hypothesis testing, be able to state the null and alternative hypotheses, find critical values for the z-test, and then state the 5 steps used in hypothesis testing. So today our first objectives, the first 2 objectives will be covered, and then tomorrow we'll take a look at finding the critical values and then the 5 steps. So we're going to split this section into 2 days at least. So this all came about because researchers were interested in answering certain questions. So let's say we had a question of interest here. Will the public prefer a certain color in a new line of fashion? For this, we would gather some data, go through hypothesis testing, and reach a conclusion. Another question or example, will a new medication lower a person's blood pressure? So hypothesis testing is a decision-making process for evaluating claims about a population. Very important definition right there. So please make sure as you copy this down, you put a little star next to it, highlight it. Very important definition. But now the question arises, how much better is better? Is there a real difference in the means, or is the difference simply due to chance, which is just referred to as sampling error? So hypotheses concerning parameters, such as means and proportions, can be investigated using the z-test or t-test. And again, pause the video to copy this information down. All right, so what is a statistical hypothesis? Well, it's a statement. It's actually a conjecture about the population parameter. It could be a question that a researcher wishes to answer, but either way, they're going to state it as a conjecture and then test their claim. So conjecture about the population parameter. It may or may not be true. So the 2 types that are going to show up in our hypothesis testing the first is called the null hypothesis. It's denoted by an H sub 0, or what we call H naught. And we have an alternative hypothesis, which is H sub 1. All right, so let's take a look at what a null hypothesis actually is. So this is a statement that says there's no difference between a parameter and a specific value. or there's no difference between two parameters. The symbol we're going to use for this, for instance, if it's our population mean we're looking at, is that mu is going to equal some specific value k. The alternative hypothesis states the existence of a difference between a parameter and a specific value. Or that there's a difference between two parameters. So what that means is, let's say the difference between a parameter and specific value, that specific value might just be the sample mean, but we could also compare like two population means. I'll just abbreviate here, difference between two parameters. Both of these hypotheses are stated together. So the statements here is that we just want to show that maybe mu is not equal to k. But sometimes our statements here, whatever hypotheses we're trying to state, can turn into specifically that mu is greater than some value k, or mu is less than. But if that's not indicated, we'd simply just say mu is not equal to k. So there's a handout I posted as a separate PDF. If you go ahead and view that, we're going to go through some examples here. So just to read along for situation A, it says a medical researcher is interested in finding out whether a new medication will have any undesirable side effects. The researcher is particularly concerned with the pulse rate of the patients who take the medication. Will the pulse rate increase, decrease, or remain unchanged after the patient takes the medication? The researcher knows that the mean pulse rate for the population under study is 82 beats per minute. So the hypotheses for this situation, we want to identify them. Eventually, we won't have to keep spelling this out, but just right now, because we're just learning this, the null hypothesis, which is H naught, would be that mu is going to equal, that population mean is going to stay at that 82. The alternative hypothesis, which is H sub 1, is going to be that mu is not equal to 82. Because it was asking, will the pulse rate increase, decrease? So change in some direction, but the direction could be greater than or less than. So we would just say that it would not equal 82. And because there's two sides to this, we're going to also refer to this as a two-tailed test, since the possible side effects of the medicine could be to raise or lower the pulse rate. All right, so let's take a look at situation B. If you want to pause the video to read this over and give it a try, you can. And if you need more time, just pause the video again. So situation B says a chemist invents an additive to increase the life of an automobile battery. If the mean lifetime of the car battery without the additive is 36 months, then her hypotheses are as follows. So now we can just go to H naught for the null hypothesis, and then H sub 1 for the alternative. And again, the null hypothesis is that mu is going to equal whatever value we're giving here, or looking at, which will be the 36. And this chemist wants to increase the life, so then they would say that mu would be greater than 36. And since greater than is to the right of something, this test is called a right-tailed test, since the interest is in an increase only. And then our third situation here, if you want to pause the video to read that over. All right, so this says a contractor wishes to lower heating bills by using a special type of insulation in houses. If the average of the monthly heating bills is $78, his hypothesis about heating costs with the use of insulation will be what? So the null hypothesis, again, is that mu is going to equal the 78. The alternative is he's looking at lowering the heating bill, so that would be mu is less than 78. And this test would be a left-tail test, since the contractor is interested only in lowering heating cost. So to summarize what we were looking at, based on the type of tests here, if what we're dealing with is a two-tailed test, the null hypothesis is going to be mu equals k. And actually, for all of them, the null hypothesis is always going to be mu equals that specific value. But the alternative hypothesis for a two-tailed test is that mu is going to be either greater than or less than the specific value, so we just say it's not equal to it. Right-tailed test means mu is going to be greater than k. And a left-tailed test, alternative hypothesis, means mu is going to be less than k. And again, k is just the specific value that the researcher comes up with before conducting hypothesis tests. All right, continuing off of the in-class examples. So this is at the bottom. It says state the null and alternative hypothesis for each conjecture. So for this first example A, a researcher thinks that if expectant mothers use vitamin pills, the birth weight of babies will increase. The average birth weight of the population is 8.6 pounds. Again, we start with the null hypothesis, then the alternative hypothesis. So take your time, go back to the summary that we just wrote out, see which type of tailed test this would be, and that helps with writing out each hypothesis. All right, so hopefully you had the mu is always going to equal the specific value, in this case is 8.6 for the null hypothesis. Alternative, because we're looking at increasing this value, this would be a right-tailed test, and mu would be greater than 8.6. Go ahead and read example B. Pause the video if you need more time, but in this example it says an engineer hypothesizes that the mean number of defects can be decreased in a manufacturing process of compact discs by using robots instead of humans for certain tasks. The mean number of defective discs per 1,000 is 18, so the null hypothesis would be that mu is going to equal 18, and the alternative is going to be that mu is less than 18. And then go ahead and pause the video, take a look at example C. All right, so let's take a look at this. So pause the video if you still need more time. But in example C, it says a psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, the mean of the scores was 73. So in this case, again, null hypothesis is always going to be mu equals. So be very careful here. It's not the null hypothesis is equal to, it's the null hypothesis is saying that mu is going to equal the 73. And the alternative, they're not sure if it's going to be higher or lower, they just know it's going to change from the 73. All right, just so these are just some things to know so far. The null hypothesis always uses the equal sign. The alternative hypothesis uses one of the following three symbols, either not equal to, less than, or greater than. Researchers must translate the conjecture, or what we're going to eventually come to know it as the claim, from words to symbols. When the researchers conduct a study, they are looking for evidence to support their claim. Usually the claim is the alternative hypothesis, also known as the research hypothesis. So again, referring to the alternative hypothesis, you might see that phrase in some examples, or the research hypothesis. If the claim is the null hypothesis, then we're looking for evidence that's used to reject or not reject the claim. And you're going to come to see that the statements we're going to use is, if the claim is the alternative hypothesis, we're going to say there's enough evidence to support the claim. Or if the claim is the null hypothesis, we're going to use these phrases here. We either reject the claim or we do not reject the claim. We never say prove or accept. We just want to stay away from those words. Anytime we're trying to use prove, we have to be able to use it on the entire population, and we're not able to here. So after stating a hypothesis, researchers design the study. Now, if we did have more time this year, we would be able to go through your whole project that I'm going to kind of just condense into a smaller project here in just in Chapter 8. But they design a study, they select a statistical test and a level of significance. And that's what you would have gone through. It would have started with the descriptive statistics section and then inferential statistics. But like I said, I'll kind of shorten that just into a little one problem project here within Chapter 8. But here, eventually we're going to come across this question: where does a researcher draw the line to reject or not reject the null hypothesis? This difference must be significant and not due to chance. And we're going to take a closer look at what it means to be significant, a significant difference here. And it just means that the difference between the sample mean and mu will be large. And there's going to be some comparisons. That's what we're going to take a look at in tomorrow's part of the lesson as we finish up section 8.1. But I just wanted to introduce you to some terminology, understanding how to write out each hypothesis, the null and alternative hypothesis for today.